This is my presentation of Lab 1 from Physics 2211. The goal of this experiment was to compare experimental data to data that has been collected from an online computational model. In this lab, the observed position data values of the golf ball should be very similar to the expected data values. The golf ball should have a constant velocity due to the net force of 0 acting on the golf ball. We should also see that the position versus time graph is linear, representing the constant velocity. There are several fundamental principles involved in this lab. Most specifically, Newton's first and second laws are very important. Newton's first law describes that an object in motion will remain at a constant velocity in a constant direction until it interacts with an outside force. In this particular lab, the ball remains in motion at a constant velocity due to the lack of force interactions. Newton's second law relates the force of an object's movement to the following equation: velocity final equals velocity initial plus net force divided by mass times delta t. In this lab, there was a net force equal to 0, allowing for constant velocity and direction. In order to properly complete this lab, the Tracker computer simulation was used. Once I recorded the video of the golf ball, I uploaded it to Tracker. From there, I determined the correct placement for the x and y axes. Then, I found the ball's center of mass. For each video frame, I determined the ball's center of mass in order to collect the position data values. If I had flipped the axes, then the position values would have been negative, since the ball would have been traveling towards the origin. In order to begin analyzing the golf ball's motion, there were a few data values I collected. I collected the start time, the end time, the ball's initial position, and the ball's initial velocity, which are all displayed on this slide. The ball's initial velocity was calculated using the first two time and position values. These specific data values that I collected are very useful when programming the computer model. This is the code I used for the computer model. I began by copying the starter code into GlowScript. From there, I made the changes necessary to properly construct the simulation. The arrows point to each of the changes I made. The first arrow points to the ball's mass, which I updated with the mass of a golf ball. Then I updated the ball's position and the ball's velocity with the values I determined from Tracker. Then I changed my while statement to equal while t is less than 0.467 because that was the amount of time that the golf ball was in motion. Then I changed the net force to be equal to 0, because as I stated previously, there was a net force of 0. Finally, I updated these last two formulas to include the net force. Even though net force was equal to 0 in this particular lab, there will be future labs where net force may not be equal to 0, so it's important to use these formulas. After creating and running the code, the predicted position data values were determined. I compared the predicted values with the observed position values to determine the relationship. As you can see, each of the data sets creates a linear graph. The linear graph is expected because it represents a constant velocity. While it was expected that the data would be very similar, the observed data skews slightly from the expected data. In order to determine why the observed data was not what the computer had predicted, I decided to create a velocity versus time graph. It would be expected that the velocity versus time graphs would be a horizontal line, since the slope of the data would be equal to the acceleration. Since the velocity is constant, there is no acceleration. However, with the observed data points, the slope of the line is not horizontal. This tells me that there were changes in the acceleration present. It is likely that these changes in acceleration were due to the path that the golf ball took during the video. If the golf ball did not travel in a completely straight line, then there will likely be variances in the acceleration and velocity. In order to improve this error in future trials, the ball should be rolled as straight as possible. The fewer deviations from a straight line will lead to a more constant velocity and a lack of acceleration. There are several important conclusions that can be made from this lab. To start, a net force of 0 leads to a constant velocity with constant direction. Newton's first and second laws are both very crucial in the study of an object's movement. If the net force is 0, the amount of pushes and pulls is unable to be determined. This is because there are many different types of forces, such as gravity and friction, that must be accounted for. Also, since the net force is 0, there would be no way to differentiate between the different forces. Finally, and very importantly, this lab showed that the value of computer simulations when determining the predicted motion of an object and in physics overall.